Hey everyone, so today we're going to be taking a look at section 1.4, which is about measuring angles. So to get started, the first thing we need to do is define what an angle is. An angle is formed by two rays with the same endpoint. The rays are called the sides of the angle, while the endpoint is called the vertex. Now, a big part of this class and going forward is going to be all about naming the angles. We need to be able to communicate with one another in what we're talking about. So there are three ways that we have to name an angle. The first way is just to label its vertex. So here, number one, we have just angle A. So if we look at our diagram over here, it's very clear to see which angle we're talking about. There's only one angle available, so it's angle A. We have to be careful with this form just because you can run into a situation where the name is a little vague, where A could be the vertex of multiple angles. For example, if I look at this setup here, where I could have multiple angles that are angle A. Angle A could be this top angle, this bottom angle, or it could be the whole angle. So using just its vertex works sometimes. It really depends on the situation. The second method here, this way always works and is probably the most common way to do it. What you do is you pick a point on each ray and then you use the vertex in the middle. So for example, in our diagram, the angle could be angle BAC, or you could go in reverse and it could be CAB. Both of those are acceptable. The one big takeaway is the vertex is always in the middle. So BAC, CAB, A has to be in the middle. And then the last way is to use a number. And the number method actually works really well. The only catch is that the number has to be in the picture. So in our diagram, they do have a 1 here. So it's very easy to refer to something as angle 1. But in our example that I was drawing above, I don't have any numbers in this picture. So if I was like, oh, look at angle 2, well, because there is no 2 in my picture, no one will know what I'm talking about. So if you are drawing a diagram, you can feel free to label angles however you want. You can be like, oh, this is angle 2, this one's angle 3. That's totally fine. But if the number isn't already there, I would refrain from trying to name it using a number, because if it's like an automatic grader or something with a computer or an end of course exam, they might not know what you're talking about. If you're doing an assignment in class and you have a human grader and you list an angle as angle 1, like our image down here where it's talking about exterior and interiors, if you put a 1 and then talked about angle 1, me as a human grader, I would definitely know what you're talking about. So it's one of those things, depending on the circumstances, using just the vertex is very situational. You just need to make sure that there is no ambiguity of what angle you're talking about. The second method always works and is usually the go-to method. And then number 3, using a number, it's probably the most convenient method, but it does require, in many circumstances, having a human look at it rather than a computer looking at it. If the angle is already numbered, feel free to use the number, but if not, I would go with naming method number 2, using the 2 sides and the vertex in the middle. Now, when talking about angles, we're going to have something called the interior and the exterior. So the interior is, as it sounds, it's anything on the inside of the angle. So it's the smaller portion here. And then the exterior is literally everything else. So you can be inside the angle, that's the interior, or you can be outside the angle, which would be the exterior. Example 1, so they're asking what are 2 other names for angle 1? So I'm going to go ahead and just highlight the angle that I'm talking about. So they're talking about angle 1 here, and that is going to be my red angle. So I can't use the number method because they've already called it angle 1. We can't really call it angle M because we don't know if angle M would be angle 1, if angle M would be angle 2, or if angle M is the entire angle, angle JML. So we're going to use our second method. We're going to pick a point on each side and put the vertex in the middle. So our points are J, N, and K. So the first name I'm going to use is JMK, and then I can reverse this and be angle KMJ. Both are completely valid ways of naming this angle. All right, so our first postulate for this section is the protractor postulate, and this is very similar to the ruler postulate from the last section. Essentially what they're saying is that we can measure angles using a protractor. So what they're saying is that we can have a one-to-one correspondence with real numbers from 0 to 180 on a semicircle. And depending on where the rays of the angle line up, we can figure out the coordinates or the measurement of the angle. The measure of angle COD is the absolute value of the difference of the real numbers paired with ray OC and OD. So what this is saying is, if you were to look at the protractor, see where the two sides are. The sides of the triangle were OC and OD. So you want to line up, well, what number did OC land on? What number did OD land on? And take the difference. And again, remember, when we're talking about angles, we're talking about positive numbers. So whatever the difference is, if you get a negative number, make sure to take the absolute value and get positive. And this will leave us with 4 types of angles. We have acute angles, which are between 0 and 90 degrees. We have a right angle, which is exactly 90 degrees. Obtuse angles between 90 and 180. And a straight angle, which is exactly 180. Also note that in this class, we're not dealing with angles greater than 180 degrees. Of course, they do exist. You'll see them in other math classes. But when we deal with them, we run into issues about what is the interior and what is the exterior of an angle. For example, if I were to draw a 170 degree angle, that would be starting here and going all the way around here. This would be 270 degrees. What is the interior of the angle and what is the exterior? Well, according to our definition, the exterior would be all of this, and the interior would be, or the exterior would only be here. And because of this, we don't deal with angles more than 180 degrees. What we would do in this situation is we would actually just measure the complement of the angle, or not even the complement, but we would just measure the smaller of the two angles. And then we would have a clearly defined interior and a clearly defined exterior. Here in example 2, they're asking what are the measures of angle LKN, angle JKL, and angle JKN. And then they ask us to classify each angle as acute, right, obtuse, or straight. So my advice here is always just highlight the angle that you're trying to measure. So the first angle is LKN. So angle L, or point L is over here, K is the vertex, and then N is all the way over here. So we're dealing with a rather large angle. Now, if you look at a protractor, we do have 2 measurement systems. We've got the inside and the outside. So here the inside is starting at 0 and the outside is starting at 180. On the other side, on the left side, we're starting at 0 and we have 180. So to use a protractor, you have to stay consistent whether or not you're on the inside of the angle or the inside of the protractor or the outside of the protractor. Honestly, it's totally up to you, so it really doesn't matter. I'm going to use the outside of the protractor when I solve this problem. So my coordinate here, it's a little hard to see because it's covered up, but this is between 30 and 40, so this is a 35 degree measurement. And because I'm staying on the outside, my number over here is 180. So if I want to find the measure of this angle, the measure of angle LKN, well, that's going to be equal to 180 minus 35. So the measure of angle LKN is going to be 145 degrees. Now, the second part they want is this an acute, right, obtuse, or straight angle? Well, this is going to be obtuse because obtuse is between 90 and 180. So this is an obtuse angle. So they've got two more angles they want us to look at. The next one is JKL. So J is right here, K is the vertex, and L we used in the first one, it's over here. So we know that if we're using the outside scale, we still have L is at 35, J is going to be at 90, so the measure of angle JKL is going to be 90 minus 35. So the measure of angle JKL must be 55 degrees. So would this be acute, right, obtuse, or straight? Well, because it's between 0 and 90 degrees, we would say that this is an acute angle. We've got one more angle to look at, angle JKN. So J, K, and N. Well, luckily, these are points that we've used before. If I'm sticking with the outside scale, J is at 90, N is at 180. So the measure of angle JKN is 180 minus 90. So measure of angle JKN should be 90 degrees, which makes it a right angle. On this slide, we're talking about congruent angles. Congruent angles are angles that have the same measure. So this is very similar to congruent segments. Congruent segments have the same length. Congruent angles have the same measure. So when talking about measure of angles, we always use this little lowercase m so that we know we're talking about the number, we're talking about a measure. And when we want to talk about the angle itself, we're going to use congruency. Angles can be congruent where measures can be equal. So to mark congruency, there are a couple different ways that people do it, but our textbook, what they do is they use this little arc. So angle A has a little arc, angle B also has a little arc. That means they are congruent. Other textbooks that I've seen, well, I guess let's stick with this. So if I drew an angle with two arcs and another angle with two arcs, that would say that all angles with two arcs are congruent. The other way I've seen this done is people will put like, every angle will have an arc and they'll put little tally marks. So they'll be like, oh, this angle is congruent to that angle. Kind of like the same notation we did with segments. Our book uses numbers of arcs, where other books may use the number of tally marks on the arc. So for our case, just look at how many arcs they have. Is it a 1-arced angle, a 2-arced angle, a 3-arced angle, etc. Where you may see, like if you have a worksheet from another book or you take another class later, that they'll start using the tally marks. We have another postulate here. This is the angle addition postulate. And angle addition postulate says if point B is on the interior of angle AOC, then the measure of AOB plus the measure of angle BOC is equal to the measure of angle AOC. So what this is really talking about is that if you've got two angles that share a side, kind of like these two, you can add them together to get the entire angle. So this is very similar to the angle addition postulate. And in a future section, we're going to have an area addition postulate. It's really just saying that you can add these shapes together to get the bigger shape. Two small segments added together get you a big segment. Two angles added together get you a big angle. And soon we're going to have a bunch of little sections added together will give you a big section. Here in example 3, we're going to use the angle addition postulate to figure out the measure of these angles. It tells me that angle RQT, which would be the whole angle, so angle RQT, the whole angle here is 155 degrees. They're asking what are the two smaller angles, angle RQS and TQS. So if I use the angle addition postulate, I know that the measure of angle RQS plus the measure of angle TQS should equal the measure of the entire angle, angle RQT. Now, I know the value of RQT, it's 155, and the other ones, they're given with variables, but I should be able to just solve for X and then plug in, kind of like the problems that we did in the last section. So RQS, this looks like an O, but it's supposed to be a Q, RQS. And RQS is 4x minus 20. So 4x minus 20 plus the measure of TQS, it's 3x plus 14, should equal the whole angle 155. So from here, we're going to add the common terms together. So 4x plus 3x is 7x. Negative 20 plus 14 is negative 6, and that will equal 155. To get x by itself, we're going to add 6 to both sides. And that gives me 7x equals 161. I'm trying to figure out what x is. So if I divide both sides by 7, you may need a calculator for this, but I believe x is going to be equal to 23. Now, again, the rookie mistake here is once you get x equals 23 to move on to the next question. But in reality, what we need to do is we need to plug in to find our angle values. So if I plug in 23 for x, I should be able to figure out what these angles are. So for RQS, it's going to be 4 times 23 minus 20. So 4 times 23 is going to give us 92 minus 20, which is going to be 72. So this is the measure of angle RQS. And now for TQS, we're going to plug in 23 again. So it's 3 times 23 plus 14. So this should be 69 plus 4, which gives us 73. So the measure of angle TQS is 73. Now, how can we double check our answer? Well, to check our answer, all we need to do, oh goodness, this isn't plus 4, it's plus 14, meaning this should be 83. That's my mistake. So to check our answer, all we need to do is add our two angles together, 72 and 83, and see if that does equal 115, which 72 plus 83 does equal 155. And this is a very good indication that we did the problem correctly. Notice if I had actually made the mistake of just doing 69 plus 4 rather than 69 plus 14, I would be able to catch my mistake by realizing that 72 plus 73 did not equal 155. So it's always good to go ahead and check your answer at the end, because if you're going to do a problem for 3 minutes and you can check it in 10 seconds, it's probably worth doing to make sure that you got everything correct and you're not going to miss credit on a silly mistake. Example 4 is very similar to example 3. We're going to be using the angle addition postulate, but we do need to pull a little bit more information from our problem. Here it says angle DEF is a straight angle, and then they're asking what are the measures of angle DEC and angle CEF. So they're asking what are these two angles. So in the last problem, they told us what the whole angle is equal to. And this problem, they're telling us that it's a straight angle. So fortunately, we know that a straight angle is 180 degrees. So here where I see straight angle, what they're really saying is that this is 180 degrees. And from here, it's just like example 3. If we add the two smaller angles together, we should get the whole angle. From there, we can go and solve for x. Once we have x, we can plug in, and then our final thing is to check our answer. So the measure of angle DEC plus the measure of angle CEF is equal to the measure of angle DEF. So angle DEC is 11x minus 12. Angle CEF is 2x plus 10. And angle DEF is the straight angle at 180. So from here, we're going to combine like terms. 11x plus 2x is 13x. Negative 12 plus 10 is negative 2, and that equals 180. From here, we're going to have to add 2 to both sides. And I'm going to get the 13x equals 182. So to get x all by itself, I'm going to divide both sides by 13. This might be difficult to do in my head, so I'm going to plug it into a calculator. 182 divided by 13 gives me 14. Maybe there are people out there who would just do that one in their head. X equals 14. So again, the next thing I'm going to do is I'm going to plug this in. I can't tell you how many students I've seen, they get x equals 14, and then they move on to the next problem. You still need to plug in. So if I'm looking at DEC, so the measure of angle DEC, well, that's 11 times x, which is 14, minus 12. So 11 times 14 is 154, minus 12, which will equal 142 degrees. So the measure of angle DEC is 142. Now, to get the other angle, the measure of angle CEF, well, that's 2 times 14 plus 10. So 2 times 14 is 28 plus 10, so that gives me 38. So I'm saying that the measure of angle CEF is 38. So double checking my answer is 142 plus 38, 180, and the answer is yes. So I'm fairly confident that I got this answer correct. So this is the end of our lesson. So we're going to have the lesson check. And this is just a brief overview of everything we talked about today. So it says, use the diagram to answer the following questions. And number 1, they're asking, what are 2 other ways to name angle 1? So angle 1, I'm highlighting it in red. So we should not use angle B, because I don't know if angle B is ABC or if it's angle CBD, or even ABD if that matters. So I'm going to use the 3 points. I'm going to use A, B, and C. And then I can reverse it to do C, B, and A. So my first is ABC, and I could also do angle CBA. For number 2, the measure of ABD is 85. What is an expression to represent the measure of ABC? Ooh, okay. So they're saying that the entire angle ABD, I'm highlighting it in green, is 85. And they're asking, what is an expression to represent the measure of angle ABC, the red angle that we're starting with? Well, here's what I can say. The measure of angle ABC plus the measure of angle CBD should equal the measure of angle ABD. This is from the angle addition postulate. So the measure of angle ABC plus, well, the measure of CBD is just x, and that should equal the measure of ABD, which is 85. So to get ABC all by itself, the measure of angle ABC, I'm going to subtract x from both sides, getting 85 minus x. That way, if someone ever tells me what x is, I'll immediately know what the answer to the measure of ABC is. And then for number 3, they're asking what type of angle is this? Well, remember, we've got acute, which is less than 90, right, which is exactly 90, obtuse, which is greater than 90, and then straight, which is exactly 180. So ABC, at the largest, if x equals 0, I'm going to have an 85-degree angle. And I know that angles have to be positive, so x can't be a negative number, meaning it's going to be smaller than 85, which is going to have to give me an acute angle. All right, lesson check again. So we got one more problem here. And it says that your classmate concludes from the diagram that angle JKL is congruent to angle JKM. Is your classmate correct? So this is a tricky one, and this is also a common mistake that people make. They definitely look like they're equal. This actually looks like they're two 90-degree angles. But do I know that? And the answer is no, I don't. It definitely looks like it's true. But what if in reality this is actually a 91-degree angle and this is an 89-degree angle? Now 1 degree is kind of hard to tell with the naked eye. I would need a protractor. And it's one of those things that no one is ever saying that drawings are truly to scale or done accurately. So you don't want to make an assumption here. So the mistake that your classmate is making here is by just assuming that the picture is exact. Where in reality, we need to note that people aren't perfect, so drawings are not necessarily perfect. And unless they give us some kind of indication that these are right angles, we have no reason to believe that they are right angles. So they're just making an assumption, and that's their biggest mistake here. So some closing thoughts on this section. I always think that this section is very similar to 1.3, which is about measuring segments. So we had, just like we had the segment addition postulate, now we have the angle addition postulate. We have the ruler postulate, now we have the protractor postulate. So hopefully after these two sections, you're feeling pretty comfortable. Our next section is about angles, some more. We're going to talk about like angle bisectors and special types of angle pairs. So if you are feeling a little confused, I would highly recommend rewatching this video, maybe even rewatching 1.3 because they're so similar. And if that's not helping, make sure you reach out so we can work something out. And if this is making sense, make sure to get on Classroom, do your homework, and go ahead and move on to the next video.